everyone, my name is Chris Harris and I'm from AlleryTutors.com, and welcome to this video on an introduction to alcohols. So in this video, like I say, we're going to look at different types of alcohols. We're going to look at nomenclature, how they're classified, solubility and boiling points, that's the properties, and we're also going to look at some of the uses as well. So this is going to be a short and snappy video looking at some of these basic things. Okay, so alcohols always have an OH group on the end of them, or we call them a hydroxyl group. They have the general formula, which is CnH2n plus 1 OH. So this is the general formula that we use. Now, naming them is actually really important. So I'm going to show you how we name some of these alcohols on the board here. So you name them in a very similar way to how you'd name an alkane. So you'd start off with your prefix is just the name of the alkane. So in this case, it's 2. So this is eth, and then we just end it in ol at the end. So this is this first one is actually ethanol, so we'll write that down in, let's write it in blue. Okay, so this is ethanol. Nice and simple. Okay, so let's look at the next one. So this time we've got an alcohol group in the middle. Because we have 4 carbons in here, we now have to specify which carbon number the OH group is sitting on. So you can see here that if we start from this side, that will be carbon 1, 2, 3, 4. If I start numbering from this side, it's going to be 1, 2, 3, 4. Now, like with any other nomenclature, whether it's a haloalkane or any other type of group, you must make sure that you pick the lowest number carbon. So in this case, it's 2. So this one is going to be, we've got 4 carbons here, so that's going to be butan, 2, ol. This time, what's a bit different is actually the 2 now sits in between, so it doesn't actually start at the end. So this is butan 2-ol. And we're stating exactly where that second carbon is. That's really important because the alcohol could appear on the end carbon, in which case it would be butan 1-ol. So you've got to make sure that you are specifying your numbers and you separate letters with numbers with a dash as well. Okay, coming on to this one. This one's a little bit more trickier because we've got 2 alcohol groups sitting in this this molecule here. So this one is the same. It's still butan, so we're going to put butan on the bottom. This time we've got 2 alcohol groups there. One sitting on the second carbon, the other one's sitting on the third carbon. So we're going to call this butan 2, 3, and it's going to be di-ol. We must put 2, 3 because we're saying there's an alcohol on the second carbon and third carbon, and the di bit tells us that we have 2 of them. So if we had 3 of them, it would be triol. If we have 4 of them, it would be tetraol. So you'll just keep on going, but it's quite likely you'll get that far. So make sure you put the di in there and then end it with ol. Don't just put butan 2, 3, ol. You got the di in there as well. And then on to this one. This one again is a little bit more trickier. We need to find the longest hydrocarbon chain. In this case, it's 1, 2, 3 carbons. So and off the second carbon, we have an alcohol group, and we also have a methyl group as well. So just like in standard nomenclature of branched alkanes, this one we're going to start with 2-methyl. This takes into account this bit, and then we've got 3 carbons, so that's going to be propan 2-ol. There you go. So this one's 2-methyl propan 2-ol. Okay, so there's some nomenclature, and again I've shown you a variety of different ones there. We're now going to look at something called classifications. Now classifications tell us what type of alcohol we have, and you can get 3 main types of alcohol that you need to know for A-level chemistry. They are primary, secondary, and tertiary alcohols. They're normally given these funny little notations, like degree signs. So it's like 1 degree. That means primary alcohol. A primary alcohol is where we've got an alcohol group. The OH is bonded to a carbon, and that's bonded to one other carbon. And we represent R as just a methyl group. It could be another carbon, or it could be anything really. So it doesn't have to be methyl. It could be ethyl, etc. So an alkyl group is what we would call it. So this one's a primary. Secondary is where the OH group is bonded to a carbon, and that's bonded to 2 other carbons. So that's a secondary. An example of a secondary was this. That was a secondary alcohol, because you've got an OH bonded to a carbon, which is bonded to 2 other carbons. This one's primary. And the other one is tertiary. Now tertiary, as you probably might have guessed, is an alcohol group bonded to a carbon, which is bonded to 3 other carbons. And the last example here, this was classed as a tertiary alcohol, because the OH is bonded to a carbon, which is bonded to 3 other carbons. So that's how we classify that as tertiary. Okay, properties, very quickly. Solubility. Alcohols are generally soluble in water. However, the bigger the hydrocarbon chain attached to the alcohol group, the less soluble it is. I'm going to show you the little diagram to explain why these are generally soluble, especially the short ones like methanol and ethanol. So you can see we've got two lone pairs on the oxygens here, and we have a hydrogen there. Now, what happens is these things hydrogen bond, and a hydrogen bond exists between a hydrogen and an electronegative element such as nitrogen, oxygen, or fluorine. So in this case, you can see we've got a hydrogen on the alcohol. This can hydrogen bond with the lone pair of electrons on the water, so therefore it is soluble. But obviously, the bigger the hydrocarbon chain, the more insoluble it is, and that's because the hydrocarbon chain is actually won't hydrogen bond with water and is non-polar, so has no dipoles in there, so therefore it doesn't really dissolve very well with water. It is actually relatively low volatility though compared to its non-polar like alkane counterparts. So that means it doesn't evaporate very readily, and the reason why is because not only can alcohols obviously interact and hydrogen bond with water, but they can also hydrogen bond with themselves as well because they have an OH group on the end. So because they can do that, these strong interactions, remember these are the strongest intermolecular forces, which are hydrogen bonding. Because of these stronger forces, it means they are less likely to break up and evaporate into a vapor. So we describe alcohols relative to non-polar with a similar MR as low volatility. Okay, so boiling points, just like with any other molecule with a hydrocarbon in, the bigger the MR, the higher the boiling point, and this is because we have the bigger the molecule, we have much more van der Waals interactions, or what we call London forces, some examples call it that. So you can see here, again, we'll draw them on here. Here's a long hydrocarbon chain. I've missed off the hydrogens just for speed. Now you can see here that we have strong or lots of van der Waals forces, so I'll put VDW forces. We have lots of them, and so therefore that requires a large amount of energy, a relatively large amount of energy, to break that chain apart. So they have higher boiling points the bigger the hydrocarbon chain is on the end there. And finally, just coming on to uses, they are used for chemical feedstock, so you can use them to make other things such as ketones, carboxylic acids, and aldehydes. So you can use them to make that, and loads of other things, alkenes as well. So you can make loads of things from alcohols. Also used as disinfectant as well. So you use them in alcohol gels, you put it on your hand and wash your hands with it. They can be used in drinks, obviously alcoholic drinks, spirits. Ethanol is used in that, and antifreeze as well. So methanol is quite a common alcohol to use in that. So the stuff you might put in a car to stop your water from freezing in the wash bottle, especially when it's in winter. So there we go. There's a very quick introduction to alcohols. That's it. Bye bye.